Hello YouTube! Today what I want to talk about is holograms or holography. Here's some information off of Wikipedia. It says holography is a technique which enables three-dimensional images to be made. It involves the use of a laser interface, diffraction, light intensity recording, and suitable illumination of the recording. The image changes as the position and orientation of the viewing system changes in exactly the same way as if the object were still present, thus making the image appear three-dimensional. The holographic recording itself is not an image. It consists of apparently random structure of either varying intensity or profile. The overview in history is the Hungarian-British physicist Denis Gabor, in Hungarian Gabor Denis, was awarded the Nobel Prize in Physics in 1971 for his invention and development of the holographic method. His work, done in the late 1940s, but built on pioneering work in the field of X-ray microscopy by other scientists, including Mstislav Wolf in 1920 and W. L. Bragg in 1939. The discovery was an unexpected result of research into improving electron microscopes at the British Thomson Houston Company in Rugby, England, and the company filed a patent in December of 1947, patent GB685286. The technique was originally invented is still used in electron microscopy, where it is known as electron holography, but optical holography did not really advance until the development of the laser in 1960. The word holography comes from the Greek words holos, whole, and graph, writing or drawing. The development of the laser enabled the first practical optical holograms that recorded 3D objects to be made in 1962 by Yuri Denisyuk in the Soviet Union and by Emmett Leith and Juris Upendnikes at the University of Michigan, USA. Early holograms used silver halide photographic emulsions as the recording medium. They were not very effective as the grating absorbed much of the incident light. Various methods of converting the variation in transmission to a variation in refractive index known as bleaching were developed, which enabled much more efficient holograms to be produced. Several types of holograms can be made. Transmission holograms, such as those produced by Leith and Upendnikes, are viewed by shining laser light through them and looking at the reconstructed image from the side of the hologram opposite the source. A later refinement, the rainbow transmission hologram, allows more convenient illumination by white light rather than by lasers. Rainbow holograms are commonly used for security and authentication, for example on credit cards and product packaging. Another kind of common hologram, the reflection or Denisyuk hologram, can also be viewed using a white light illumination source on the same side of the hologram as the viewer, and is the type of hologram normally seen in holographic displays. They are also capable of multicolor image reproduction. Specular holography is a related technique for making three-dimensional images by controlling the motion of specularities on a two-dimensional surface. It works by reflectively or refractively manipulating bundles of light rays, whereas Gabor-style holography works by diffractively reconstructing wavefronts. Most holograms produced are of static objects, but systems for displaying changing scenes on a holographic volumetric display are now being developed. holograms can also be used to store, retrieve, and process information optically. In its earlier days, holography required high-powered, expensive lasers, but nowadays mass-produced low-cost semiconductor or diode lasers, such as those found in millions of DVD recorders and used in other common applications, can be used to make holograms and have made holography much more accessible to low-budget researchers, artists, and dedicated hobbyists. It was thought that it would be possible to use X-rays to make holograms of molecules and view them using visible light. However, X-ray holograms have not been created to date. Well, that's just some information on holograms from Wikipedia. Continuing, it says how holography works. Holography is a technique that enables a light field, which is generally the product of a light source, scattered off objects, to be recorded and later reconstructed when the original light field is no longer present, due to the absence of the original objects. Holography can be thought of as somewhat similar to sound recording, whereby a sound field created by vibrating matter like musical instruments or vocal cords is recorded in such a way that it can be reproduced later without the presence of the original vibrating matter. It says laser. Holograms are recorded using a flash of light that illuminates a scene and then imprints on a recording medium. Much in the way a photograph is recorded in audition, however, part of the light beam must be shown directly onto the recording medium. This second light beam is known as the reference beam. A hologram requires a laser as the sole light source. Lasers can be precisely controlled and have a fixed wavelength, unlike sunlight or light from conventional sources, which contain many different wavelengths. To prevent external lighting from interfering, holograms are usually taken in darkness or in low-level light of a different color from the laser light used in making a hologram. Holography requires specific exposure time, just like photography, which can be controlled using a shutter or by electronically timing the laser. Apparatus. A hologram can be made by shining part of the light beam directly onto the recording and the other part into the object in such a way that some of the scattered light falls onto the recording medium. A more flexible arrangement for recording a hologram requires the laser beam to be aimed through a series of elements that change it in different ways. The first element is a beam splitter that divides the beam into two identical beams, each aimed in different directions. One beam, known as the illumination or object beam, is spread using lenses and directed onto the scene using mirrors. Some of the light scattered or reflected from the scene then falls onto the recording medium. The second beam, known as the reference beam, is also spread through the use of lenses, but is directed so that it doesn't come in contact with the scene, and instead travels directly onto the recording medium. Several different materials can be used as a recording medium. One of the most common is a film very similar to photographic film, silver highlighted photographic emulsion, but with a much higher concentration of light reactive grains, making it capable of the much higher resolution that holograms require. A layer of this recording medium, e.g. silver halide, is attached to a transparent substrate, which is commonly glass but may also be plastic. Okay, well, this video is coming up on 10 minutes now, so I'm going to go ahead and stop it. Sorry for the whole shaking and moving around.